All right. Now, what are you doing here, Skylar?
I am doing distillation alchemy.
And what's going to happen? Okay, so the apple juice is going to boil. And the vapors is going to collect in the bottom of your tube.
Mm-hmm.
And then you'll have apple essence in a tube. So you're removing the essence from the what?
From the apple juice.
From the apple juice. Say it.
From the apple juice. I just said it.
Okay. And again, what subject are we doing?
Doing distillation alchemy.
We're doing alchemy.
Yes, distillation alchemy.
Distillation is the project.
I don't
Alchemy
care. That's
is
how
the
I'm gonna say
subject.
it.
Okay. So this takes just a few minutes here for it to boil. It's going to take a little bit longer because it was cold. The apple juice was cold. So it'll take a little longer.
Alright. Oh heck, I still had some drops in here.
Okay. What other stuff can you distill?
I am not too sure.
Okay.
Orange juice and even cola.
Yes.
Coca-Cola.
Okay, now I see that the flask is starting to what?
Fog up.
Mm-hmm. So it should be pretty soon.
Where are you going? Camera's better than mine. It's not fair.
Sorry.
How can you tell how long the video's been going?
I don't know.
You can't. Oh, there it is. It's the top right corner.
Okay. Distillation, from the Latin distillatio, meaning trickling, is the process of transporting fluid in its vaporized state from one vessel to another. What is the meaning of the process? Essentially, some liquids are easy to evaporate than others because they are more volatile. Thus, in case of a two-component liquid mixture distillation, a relatively more volatile liquid will evaporate faster than the less volatile one.
So should I touch it?
No, I wouldn't touch it. It's hot.
I want to touch it though.
No.
No, I really want to touch it.
Oh, we'll have to include this little video when we make your post.
I want to touch it.
Okay. Having been one of the basic processes in alchemy, distillation was thought to be a kind of magical ritual of obtaining the spirit of a liquid. In other words, its essence. You can learn even more about distillation and alchemy from this cool little video right here. It's an important process in science and the chemical industry. For instance, the process allows separation of petroleum composing fractions, which then serve a variety of needs in industrial production, from fuel, lubricants to protective layer materials for roofs and roads. In particular, the lightest fractions of petroleum, naphtha and gasoline, are mainly used as a starting material for chemical synthesis, as a fuel for car combustible engines, and is an inexpensive solvent in industry. Heavier kerosene and diesel fractions found their use as a fuel for diesel and jet engines. The remaining dense and heavy residue, the heating oils, is used as boilers fuel for lubricant production. Finally, the removal of all fluids, the solids, asphalt, are used in coatings and road construction.
Okay, I'm going to go kill it.
It's your dog.
It's not my dog. We agreed to share it. What is that thing going after?
The little boys.
What?
The little boys down the street.
So,
how did alchemy aid the development of science and industry?
It's not doing much. What did you do?
It is. It's starting to.
I see bubbles.
Yes. That's turning into vapor, which will go up down the tube into your test tube.
But it's not bubbling. Isn't it supposed to be bubbling?
It will.
I almost touched that.
Don't touch it.
Can I touch it?
Alchemists were ancient experimenters who worked with substances and studied their transformations. Despite the fact that their explanations for observed phenomenon were ridiculous, and that many, if not most, experiments were meaningless, they left behind a vast heritage. Alchemists developed a variety of approaches for analyzing substances, as well as comprehensive toolkit still used by chemists. For instance, a significant contribution to medieval metallurgy is distinguished among other alchemists' achievements. They discovered arsenic as and antimony SB used in various alloys manufacturing, and they also developed a new design of smelting furnaces.
That's wonderful. It's dripping.
So, I know, and it's going to go travel up your tube and down into the test tube.
I know how it works. It's just taking a while. Excuse me.
How do you know you were only supposed to put 150?
It was in the middle. It was in the middle.
Oh, okay.
You think I'm stupid?
No, I just wanted to see why you chose that much.
Because it was in the middle. That's in the middle.
Okay.
Wait a minute, it's past 150.
And that's cold water?